All right, so for 4.1 this is just review here. You guys know what's the explanatory and respond variable, right? So respond variable measures the outcome of the study. An explanatory variable may explain or influence changes in the respond variable. So let's take a look at the example. A random sample of 14 sales staff for a very large company was given a creativity test. Score range from 0 to 20 points, with higher score indicate greater creativity, and were evaluated on sales growth performance. Higher score indicated better performance. So in this regression analysis, which is that's chapter 5, if you don't understand that word, that's chapter 5. You don't have to worry about that now. Okay. The variable creativity score plays the role of the blank variable. What do you think? What do you think? You can just stick it out and then put it on the chat. I'll have you get a chance to do on the chat later, but for this example, just stick it out. The creativity score plays the role. Which one? Which one? What you use to predict what? The question you asked. And the response is the outcome. Explanatory is something that I use to explain something else. Give it a shot, Anthony. Good, right? Explanatory, because it's you to explain what? Yeah, the cell growth performance, right? If you have better, you have higher creativity score, it implies that you a better salesman, right? Which is true, right? I'm not a salesperson. I don't have that ability to persuade people. But yeah, so this is explanatory because you use creativity score to predict the cell's growth performance. Can someone remind me what the confounding variable is? Since from a long time ago. I call it lurking variable. But what is the confounding or lurking variable? People from the chat, you can what does it do to the data set? Is it the bad thing or is it a good thing? Is it bad or good? So it's bad, right? It messed up your result. So it's kind of like, yeah, it's kind of like your virus, kind of intruder, right? You don't want it to be there, but it's there regardless. Somehow it's kind of find its way into the data set. So most of the time it's bad, right? Sometimes maybe people, if they see lurking variable, if they do some tests and say they're lurking variable, then they may find different tests, or they may consider that lurking variable to be the main variable, but most of the time we don't want it, right? It's usually it messed up the data set. It changed the relationship between X and Y. Okay, good. All right, let's try this. Beer and blood alcohol. Just read it carefully and then put your answer in the chat for me. What is the explainer variable and what is the responder variable? Now, I didn't know that college drink a lot. I didn't know until I go to grad school. I didn't drink. I just kind of walked by when I was at U of M. Just kind of walked by the fraternity houses. Big beer bottle on the side. I'm sure they clean it right away. Not supposed to put it there. I'm not sure they old enough to drink beer or alcohol. But I remember like in the summer, like start at 6 o'clock, like music start like pumping up at the whole Ann Arbor college, the whole area in the Diag. So a lot of drinking. Number of beer you can drink. Mhm. Let's see. This is the answer. Oops, too big. All right, Anthony, number of beer you can drink, explanatory blood alcohol content. Good. Tyler, same, right? Same. BAC, I like it. Is it they call it BAC for short? Yeah. Respond. Good. And then Stephanie. Yes. Larissa, you missing your response. Number of cans. Maybe you want to say beer. Jade, drinking different number of canned beer is okay. Okay, all right, okay, there you go. All right, so all of you get it right? So explanatory will be the amount of beer that you consume, or Ohio State University student consume. So the amount of beer, or number of cans of beer. And then it's used to predict the blood alcohol level. A lot of time, people call the explanatory variable is predictor, right? It's used to predict something else. Blood alcohol. Is there an L in alcohol? Is it double L? No, just no. Alcohol. I like BAC. I like that. All right, let's try the second one, coral reefs. Make sure you answer, are they categorical or quantitative as well? Hello. Make sure people in the Zoom participate too, okay? Sometimes. All right, let's see. You guys need more time or something? For every question you gotta write, give yourself a bonus check mark. Okay, so say if you get these two right, give yourself 2 bonus check mark. So 1 bonus check mark for each of the one that you got right. Let's see, check it out. All right, Carly say explanatory is sea surface temp. Good. Respond is coral growth rate per year. Very good. Stephanie is same, both quantitative. Good. Larissa, same. Good. Kyle, Jay, good. Tyler, good. Dan, you missed a respond. Maggie, okay, good. Anthony, Dan, okay. Mohammed, condition of the coral reef. Not what I'm looking for. All right, Kareem, good. Oh, they're not categorical, right? By the way, for scatter plot and regression, your data has to be quantitative. Otherwise, you cannot plot it on the scatter plot, right? If it's categorical, what kind of plot we use? Yeah, bar or pie, right? Pie chart. Anything other than that, all has to be quantitative. So the explanatory is the sea water temperature, and the respond variable will be the coral growth rate. Coral growth rate. So my tongue little stiff today. So explanatory. I'm just gonna highlight stuff here, so it's gonna. I'll write it out. So sea water temp, and then the response is coral growth rate per year, and they both quantitative. They have to be, right? Otherwise, you won't be able to do a scatter plot. Okay, all right. So here, this slide, I'm just gonna write some stuff here, explain a little bit more about the response and the explanatory. So generally, one variable is a response variable, denote Y, because that's your outcome, right? And this variable measure the outcome of the studies, nothing new there, and it's also called the independent variable. Dependent variable because depend on X. Dependent variable. The other variable is the explanatory. A lot of time I call predictor, and especially when professor, I remember my prof in grad school, they all say predictor. They rarely say explanatory. Maybe it's easier for them to pronounce. Denote by X. It is the variable that is thought to explain or predict. Right? That's why they call it predictor. The changes we see in the response variable. The explanatory variable is also called the independent. Independent. Think of X and Y in math, right? F of X is depend on X, right? F of X and Y is the function that depend on X. Same thing here, Y depend on X. Now, a lot of time I don't use dependent variable or independent variable. I just gotta say respond and predictor. The reason being is in statistics, dependent and independent means different things. Do you guys remember the independent events? Dependent event. So it had nothing to do with probability. Okay, it's more like think of like f of x function wise. It has nothing to do with probability. That's why I kind of not using it a lot because I don't want you to confuse about the probability. Now, when you have a data, the first thing you do will be what? What would you do? I give you a data set. What did you do? First thing you do? Order. Okay. You want to order it. It's not necessary, but you graph it, right? You see what shape it has, right? What shape it has. Because it has to have a normal shape in order to do Z test and whatnot, right? So here when I have my data set, the first thing I'm gonna do is I'm gonna graph it. And then for quantitative variables, both of them, x and y, is the graph is called a scatter plot. Right? It's examining the relationship between variable x and variable y. So scatter plot display the relationship between variable x and variable y. It does not distinguish what is x, what's y though. Well, y is always on the y-axis, x variable on the x-axis, but for scatter plot is the same for it. But we're supposed to know for ourselves. For the second bullet point, it say if linear relationship is reasonable, we're gonna find a model. It's just a different way of saying finding an equation of the line to summarize the relationship. This one is chapter 5, so you don't have to if you don't get what I'm saying, it's no big deal. You get it eventually. Okay, so what does a scatter plot look like? There are 3 types of scatter plot for this class. The first 2 you're probably going to see a lot, but not for the last one. So the first one is linear, right? Just like the name indicate, everything is kind of hovering around a line. Right? It's linear. The second one is curve. It looks like a parabola. Be open up or open down, but it's curved, right? The third one is sinusoidal. So it's kind of like sine curve or cosine curve. You don't see this. I don't know about your homework, I don't see this. I see these two a lot. I don't see that much. I don't see sinusoidal much. But I'm gonna show you how to interpret it, the first 2 types, okay? I'm not gonna show you how I don't see this in the homework, and they're not that popular for this class either. Yeah, thank you, Rami. You can just speak it out, Rami. Okay, so let's take a look at the example here, and we're gonna see how we interpret the scatter plot. Rent price versus square footage. How well does the size of an apartment in square feet predict the monthly rent price in dollars? Below are the size and monthly rent prices from 8 different listings. Can someone tell me what the response variable here? Good. Rent price. Yeah, thank you. All right, so we use the size to predict how much it costs per month for the apartment. So rent price in dollars. And then the explanatory or predictor will be the apartment size measured in square feet. Usually bigger apartment costs more, right? But also depend on location as well. Okay, so here is the scatter plot. I graph it for you, so we have to do by hand. We'll do by hand next time. But for this one, I did it for you. So the title of the plot will be scatter plot, right? When you show some kind of graph, you should tell people what kind of graph it is. Right? Not everybody knows statistics. So scatter plot of rent price versus apartment size. And then on what the x-axis should be. What should I put here? What should I put here? Thank you, Anthony. Apartment size in square feet. And then for the y, it's gonna be rent price dollars. My dollar look. Okay, so say if it's 700 square feet, it costs you roughly what, 880? If it 850 square feet, it costs you roughly 960 or 970 dollars a month. Okay, so here is the step to interpret the scatter plot. First, you have to look in for the overall form. Is form, remember, with the 3 types, right? Is it linear, Is it linear, curve, or sinusoidal? What do you think? What do you think? Linear, curve? Well, it's not going to be sinusoidal, right? I don't see any wave kind of picture there. So one of the first two. Linear, right? It looked like approximately linear to me, not perfect. So approximately, I would say approximately linear. Direction, is it increase or decreasing? So it's increase mean positive, decrease mean negative. You think? Yeah, positive. Strength, I mean, how much do the point vary around from average pattern? So say if I have a line, draw a best fit line here. See how much the point deviates from this red line. That's how strong your relationship between X and Y is. For me, I think I would say moderate to strong, moderately strong, moderate. Let's say moderate. So strong. Any deviation from overall form, that means is there any outlier? Do you think is there any outlier here? Huh? Two? You think two? Yeah, sort of. This guy, let's see, how is you roughly 1,100 square feet, and then it costs you more than $1,300, like 3,500 a month. That's a lot. Maybe in a grocery store downtown or something. Costs a lot, right? So I would say there's a little bit, yeah, there's a possible outlier. Maybe this guy, I would say possible outlier. Depends. Some people think that it's not. They're not wrong. Nobody right, nobody wrong. Depend on the observer. Do you have any questions so far? People from Zoom, do you have any questions? I'm gonna try to pay attention more to you, please. Make sure that you're there. All right, so that is the example of a linear relationship, which we're gonna talk about in chapter 5. Once you have a linear relationship, you do regression. If you don't, you stop, right? Because you don't know anything else other than linear regression. Thank you, Dan. Okay, so the example 2, example 2, I got it from your book. So let's see. Does fast driving waste fuel? How does the fuel consumption of a car change as its speed increases? Here's all the data of a 2013 Volkswagen Jetta diesel. Speed is measured in mile per hour, and fuel consumption is measured in mile per gallon. What is my response variable? What do you think? Do you guys see my share screen? Is this slide?
Yep.
Right? Okay, thank you.
Is the response variable the fuel consumption?
Very good. Yeah, fuel consumption. Right? Thank you. Is that Rami? Thank you, Dan. Consumption, which is in mile per gallon. And then Dan said explanatory will be speed, which is mile per hour. Right? We use speed to predict how much fuel you use and how fast you drive. Or how slow you drive. Right? Okay, examine the data rapidly with a scatter plot. So we're gonna do it by hand. No, it's kind of tedious, but I just gotta show you how to do it. I don't think you ever be gonna be asked to graph this. I'm not sure though. I'm not sure. I haven't taken a look at the final exam closely. So first of all, I know this is a scatter plot. What scatter plot of fuel consumption versus speed, right? So on the x-axis, I'm gonna go with the smallest variable, which is 20, right? Don't start at 0 because it's useless. You don't have 0 there, so start at 20, say 20, 30, 40, 50, 60, 70, 80. Leave it or space, don't put 20 at the origin. So 20, 20, 30, 40, 50, 60, 70, I'll make 80 here. And make sure you label it. So this is speed in mile per hour. And then consumption is a C. Consumption started at what? Smallest is 39.1. So I'm going to start at 30. And then the largest is 67.9. So I'm going to stop at 70. So from 30 to 70. 30, 40, 50, 60, 70. And this is fuel in mile per gallon. Okay. 20, 49.0. So at 20, 49.0. Roughly, I say roughly here. Oh, I'm gonna use red. Say roughly here. Okay, let's see what else. 30, 67.9. 67.9. So I would say roughly here. At 40 is 66.5. A little bit lower than 67.9. And then 50 is 59. 15. Oh, I'm so sorry. I did something. 67. My bad. 67. Here. And then 40 will be here. And then 59 is here. Okay. I'm just gonna eyeball it. 60 is 50.4. That was it here. And then 70 is 44.8. 44.8, roughly 45. And then last one is 80 is 39.1. 80 is 39.1. Okay, I have a question for you. Does it make sense to you? And I'm gonna try to draw a pattern. Okay, you don't have to do this little line, I just want to show you what it looked like. For me, if you drive very fast, do you think you consume more gas or less? For me, I thought you consume more gas. No, yeah, I mean highway mileage is better than the regular road because you don't stop and you don't. So I guess it makes sense, huh? Well, I guess so you don't stop and you start again. It's kind of momentum, right? So I guess it makes sense. Okay, all right, but let's answer our question. Describe the form of relationship. It is not linear. So what it is? Curve, right? Curve. It is. And then you say the relationship. Oh, is curve. Okay. All right. So let me say some more. This curve a little too short. I'm just gonna say some more. So it's curve, and what happened at the two extreme, at the two ends? What happened here? You have lower fuel consumption, right? So lower fuel consumption at the two ends or two extreme. I'll say two ends. What else? It's kind of increase toward the left. Or high, I would say high. I would say it's high, higher toward the left. And what is steadily decrease as you steadily decrease as speed increase. Maybe that's why when you get the highway mileage, it makes sense because why does it make sense? What would you say? Because it costs more fuel. So if you have a steady speed, that's cost less fuel, right? You don't brake in a certain and then you start again. So I think it's kind of makes sense, right? Too slow right here. This part right here. I mean, you in local road, you stop and you speed up again. You stop, you speed up again. Over here, more like a highway mileage to me. Okay, all right. It does not make sense to describe the variables as either positively associate or negatively associate. Why? Why?
Is it because there's no consistent trend?
This trend, I see trend, but what kind of trend here? We only talk about positive or negative only if your form is what?
Linear.
Yeah, if it's linear, right? Then you have a lower end and high end. Here you don't have a lower end, right? Both ends are low, right? So so yeah, because it's not linear. It's not linear. Since it's not linear, it does not make sense to describe variable as positive or negative. You can say more. Let's see. I would say I think in the textbook they use the word below average. I'm gonna say that so that will help you with the homework. Below average values. Let's see. Below average values of fuel consumption. If it's up to me, as long as you say it's not linear, then I'll take that answer and give you 100%. But I think your homework they want more. Consumption. Below average consumption at consumption at the two extreme. I would say that. You see something like this on your exam. I'm sorry, not exam. Your homework. And I think they use the word below average, something fancy. Is their relationship reasonably strong or quite weak? Remember, the strength depend on what? Depend, according to the definition, the strength depend on how scattered are you, right? How scattered is your graph? If it not too much scattering, then it's strong. If it a lot of scattering, right, then it's not very strong. So what do you think? How strong is your graph? It looks pretty strong to me. If it's not strong, then say one point right here, the other point over there, right? Everybody just kind of out of that path. So it's kind of follow that path. So it's strong. When it's strong, it's good because you can use it to predict things, right? So there's a strong relationship between X and Y. It's a good news because you can use it to predict whatever you want to predict next. There's very little scatter. in the plot. It's a good thing. Now for this class, you guys don't have the tool to analyze this kind of data set. This is much more complicated than you think would be. This is like grad school stuff. But we still have to tell you what it looks like. But for us, we can do linear regression, right? Everybody know linear formula, right? Y equal ax plus b. That's simple enough. Okay, let's take a break, and then when I come back, I'll start 4.5. Oh, I don't want energy. Recording before I forget. No. All right. Hidden message. Can you interpret it as message? People from Zoom too.
Is it decision?
Yes, it is the word decision.
Split decision.
Yay! Who was that?
Me.
Is it Roman?
Yeah.
Yeah, Roman. Good on you, Roman. Yeah, the decision is the word being split, so split decision. Okay, the second one a little bit harder. What do you think? Anyone here? Oh, Zoom people got one. What do you think? The word time is very long. Yay! Long time no see, right? Long time no see. Good for you. Well, it's longer than ABC. Big time no see. You getting there. All right, I hope it's fun. Okay. If you guys have like your pet picture, you can send it to me and I'll share it to the class. It's called Picture of the Day. I do it all the time, but kind of forgot this semester. Just send me your picture of your cat or whatever picture you comfortable sending me. I'll share it to everybody during class. All right. Okay. So 4.5 is correlation. Now, a lot of time when you eyeball stuff, well, I say that the relationship is strong, right? How strong is strong? Well, we don't know the exact value, right? So that's where we come to math, right? You need some tool that can compute the magnitude of the strength, right? For us. So that is called the correlation. So correlation of R is the measure of strength of a linear relationship. Remember, R only measure the linear relationship, not curve, not sinusoidal, right? It has to be linear in the first place. Between X and Y. Maybe it's a good thing to remember this for your quiz. The property of R is R gonna range from -1 to 1. So it could be -0.5, -0.3, right? 0.4, 0.7, whatever. -1 to 1. The size of R indicate the direction of your relationship. Oops. Direction of relationship. And the magnitude of R indicate the strength. What does that mean? That means when you're closer and closer to 1, the strength is strong, right? You have strong relationship. If it, the R is further away from 1, say 0.2, 0.3, that's weak, right? That's considered weak. If it closer to 0, then it's weak. But if it closer to 1 or -1, that means strong, right? Positively strong or negatively strong. Okay, so that's R. So that's your R. It's called correlation. I'm sorry, coefficient R. Correlation coefficient. Remember that name, okay? Because there's another one is called R square. Coefficient of correlation coefficient. So let me mark this up. Okay. Yeah. So if it close to -1, it's called a negatively strong. If it close to +1, then it's positively strong. But if it near 0, then it's weak, right? So instead of having the steep slope, your slope is kind of like flat, no slope. All right. So how do I calculate R? Here is the formula, and I'll show you how to calculate it. So R is equal to 1 over the sample size minus 1. And it's equal, and times x1 minus x bar divided by standard deviation. Do you guys remember the standard score formula? Let me recall. Just recall here. Do you guys remember the standard score formula? It's equal to what? It's equal to observe z-score. If you want to think of z-score, what observe minus the mean, right? Divided by standard deviation. Just like that. You observe number one, your first data point, the first x data point, your first y data point, minus the mean of x minus the mean of y divided by standard deviation x, standard deviation y. So x bar is the sample mean of x, y bar is sample mean of y, s of x is a standard deviation of x, s of y standard deviation of y. Because there's two variables, right? So you can have two columns, right? Column x and column y. So you're gonna have two sample means and two standard deviations. Plus the second, so x1 minus x bar divided by standard deviation times y1 minus y bar divided by standard deviation, and then plus the next observed point, right? Next data point, x2 minus x bar divided by sx, and y2 minus y bar divided by sy, and all the way to xn and yn, right? More compactly, we write like this instead of write all out like that. We use the summation to indicate the addition between those two products, or those bunch of products, right? So these formula right here, this part maybe I'll highlight in blue. The two right here, they are called standardized. Standardized. And I'm gonna call xi minus x bar divided by standard deviation of x is z sub x. And then I'm gonna call this guy is z sub y. Right. Standard score of x, standard score of y. And I'll show you how to calculate this. So far, so good. Okay. All right. All right. Let's calculate the correlation using the coral reef data set again. The same one we answered in the beginning. Here they add the table for you for the sea surface temperature and then the growth rate. Bless you. Okay, so if you click on that coral reef data set, maybe I'll share a screen so everybody can see. Before I share screen, actually I want to say something. So here I use R to make a scatter plot. It's just a code for you if you want to know. You don't have to know. Here is the scatter plot for sea surface temperature versus coral growth rate. What kind of direction is that? What kind of direction we see here? Yeah, decrease. Thank you, Dan. So if it decreased, then what kind of value you expect R to be? What kind of value you expect your correlation coefficient R to be? Negative, right? So your answer should be some negative. What is well, explanatory versus siege surface temperature? We were talking about that in the beginning. Okay, so here, what they want you to do, they want you to find the correlation R step by step. You wish to route up to 2 decimal places. This is for your homework. I'm not gonna route it on because it takes time. On your homework, I think you should. If they want you to route, you should route it. First, find the mean and standard deviation of each variable, x and y, and then find the 6 standardized values for each variable, and finally use the formula R. I'm going to show you step by step how to do this on Google Sheet. You can do it on your calculator if you want. It's not difficult. So let me share a screen here. Everybody can see what I'm doing. If you click on the data set, it should get you here. I hope everybody's here. So X bar, that's your sample mean of X, so equal average. We did this many times. Then you highlight the X column, which is sea surface temperature. So roughly the average temperature is 26.46. I would suggest it's Celsius degree, because this Fahrenheit is very cold, and colder we talk about tropical, right? So it's Celsius. Y bar equal average of your growth. So far so good. You guys want to follow me or just watch? All right. What kind of command should I use for my standard deviation? The standard deviation of X. STDEV something, right? If you type a couple letter, it'll appear for you. So this one, enter. Right there, standard deviation of X is 0.22. On the homework, they're gonna ask you to route it to 2 decimal places. So I'm not gonna do it here. It's not homework. Same thing with for standard deviation for Y. So far, so good. So that's easy. All right. So the green column, this right here, is asking for your standardized values of X. Right? So standardized values right here. That's xi minus x bar divided by standard deviation of X. So equal xi is the first data point of X, or x1, right? Minus, do not click on the X bar. Oh, please. What is it? Okay, I thought I lose everything. I don't know why it does that. Again, equal. Come on, equal. I have to sign in. Don't know why I do that. Please don't lose. Oh, thank God. All right, continue. ZX, Z of X, standardized of X equal. I'm gonna put parenthesis here. The first data point of X, so X1, which is 26.7. Click on that cell because it's gonna change, right? XI change. What not change is what? What does not change is your X bar and your SX, right? So instead of click on the cell, I know that you guys are gonna be tempted to click on the cell X bar and then S of X, but don't do that because why? As you drag down, it's gonna implicate the X bar of what? C3, C4, right? Which we don't have, right? So I'm gonna put a fixed value here. So minus 26.47. And then divided by, same thing, do not click on the SX, it's not changing, it's the same for every formula. The only thing changing is XI, 0.23. Oh, something wrong. Minus point. Oh, I have a point there. So, all right, there you go. And then, yes. Same thing over here, equal your first data point of the Y column, which is this one. And put the okay. Put the parenthesis there. Minus Y bar is 0.86. Type it down. Don't click on the cell. Divided by SY is 0.04. There you go. That's your standardized values. You can do that here. It's not difficult. Just take time. On your homework, you don't want to do that. Okay, so the second step is what we want to do. We want to multiply them together. So equal this times this. Right there. And then what do we do next? We add them up, right? Add them all up. So the sum is just add all of these, standardize up. Sum. I just want one value. So right there, the sum is negative. And then the final one is you're gonna put the 1 minus 1 over n minus r. What is my sample size here? What is my sample size here? I know it's like it seemed like a very simple question, but somehow people have a trouble answering it. What is my sample size here? 6, right? I hope no one is say 12 because x, y, right? They 1 point. Think about your Cartesian graph, right? They 1 point. So there's 6 points here. Each point have 2 coordinates. Right? So 6. So okay, so it'll be equal 1 over 6 minus 1, so 1 over 5. 1 divided by 5. And then you multiply the sum, right? Multiply that sum, which is here. Right there, that's your final R. If you want to do it fast, we call this a one-shot R. The command is equal Corel, I think. Double R, Corel. It's a Pearson product. And then the column Y. Oops. No. Column Y. Y first. It's one Y first. Y. Because the regression. And then column X. Oh, my bad. Let's say B2 to B7. There you go. There you go. They're pretty close, right? They're pretty close. So you do by hand. Okay, so on your homework, I think there's some problem they ask you to do step by step, and some problem if they don't ask you step by step, you can use this. I hope that's helpful. Okay. For I'm not gonna bother to show you how to do in R. But, you don't need to know. Do you have any questions so far? People from Zoom, do you have any questions?
I have a question, but it's not
Mm-hmm.
like directly related to this.
Okay, what is it?
When we take the final, if we have questions that require software, stuff like this,
Mhm.
Are we allowed to also use our computers on it, or because I know?
No, I look at your final. It's not require any software at all. Yeah, no. There's one thing though, since you mentioned it, you can remember how I skipped table B? Table B. I'm gonna show you how to use it. Not the table, not the table. I'm gonna give you a random number and I'll show you how to pick a random number from the list I give you. And that's one of the questions from your finals. I'll tell you what it is. It's extremely similar to the final. So if you guys listen, you should have you should get it correct on that answer. But no, you don't need any special software. Everything by hand. All right. Is there anything else? Is there any other question? We almost there. Let's see. Yeah, we almost done. We're almost done. Okay. All right. So let me go back to. Let me stop share this. Next semester, I'm thinking not letting you guys Zoom. Because it's really difficult for me. If you guys here, all of you here, I don't have to keep going back and forth between my iPad and then the computer. It's not labor, it's messed up my mind a little bit. Okay? So too many things at once, I got confused. Okay, so explain how your value for all match the direction of linear pattern. Now, because the direction of the graph is negative, thus imply correlation coefficient R should be negative as well. And then I'm going to put a note here. See the link above. We use this. Done. All right, so okay, so let me make some fact about the correlation, and then we're gonna have a little exercise here. Thinking doing Kahoot. Should we do Kahoot? I don't have time. Should we do Kahoot? Do you guys want to do Kahoot? Oh, you know, I'll save it for the final. We do Kahoot in the final, and I'll make the extra credit as well. It's a lot of extra credit for you guys. That was, okay, so almost done. So okay, so some character about the correlation coefficient is that, like I said at the beginning, there's no distinction between the x variable and the y variable, right? It's all it's know is that there's some kind of relationship between the two variables, but it does not discriminate between the two, right? It's all the same for correlation coefficient is all the same, but for us, it's different for us, right? We're supposed to know ourselves. R does not change the units if R does not change. R does not change when we change the units of measure of x and y, or both. Can someone tell me why? Can someone why R does not change if you change? Say, for example, up here. Instead of in Celsius degree, I'm gonna change it to Fahrenheit, and R is still 0.8 some negative 0.8 something. It does not change. Why is that? Someone tell me why. You done this before. I'll show you a little hint. I'll show you a little hint. Something about with this formula. So it's always come back to the formula. That's how you put it with R. Why when I change the units, it does not change R? Anyone from Zoom want to give it a shot? Hmm? No, because no, not really. It's kind of true because sample size here is the same, but also something else. Let me remind you, Chica, I'm not sure people here can see. I'm gonna draw something on the board. When you have a normal curve, say IQ score average is, its normal average is 100, and then standard deviation say 15. And then what do I do? What do I do to get to? What do I do to get to a curve that is normal of 0, 1? You can see. What do I do? What is the process between this curve to that curve? Between the left to the right. How would I get from the left to the right? What the process do I do? What is that? What's that distribution called? I know it's normal, but what else it is? What kind of normal? So an S, and a T, and a D, A, N. Standardize, right? You standardize. You standardize. Standardize. Remember Z equal X minus X bar divided by standard deviation, right? So when you divide it by standard deviation, you standardize them. So everything's the same, right? Whatever you have here, say height, weight, you standardize to that curve, right? Normal 0, 1. So because we standardize the value of R in the formula. If you change the units of X or Y or both, R does not change. Positive R indicate positive association between two variables. Negative R indicate negative association. R is between -1 and 1. Okay. All right. So now let's finish this and I'll tell you about your quiz. All right. Let's try this. I'll take a minute and maybe I'll do this. I'll call this is A, B, C, D, E, and F. And then you're supposed to fill in the correlation values given above for each of those. Try that. And put it on the chat privately to me. Jade, are you asking to use the calculator? Now on your calculator, if they ask you to do that, it's going to be by hand. So you still have to go through all that steps. Does that make sense? I show you how to calculate the standard deviation, the sample mean and standard deviation in the beginning of the semester. Is in one of the slides. I'll post it again. Maybe I'll post it again. Let me get my calculator out. All right. You can look it up, see how you do regression on a calculator. Second bar. You guys have your own slides, right? Can I move it? Is that okay? Pull up your own slides. No, right here. Jay, in chapter 2, Jay. In chapter 2. Okay, that's chapter 2. So Jay, are you still out there? Say something for the, oh, okay. Okay, so if you go to chapter 2, I post the lecture note on Moodle. There's step to plug in your data set. Okay. Here I show you how to plug in your data set. Here you need L1 and L2, right? And then you're gonna go to count var stats. And then it'll show you the sample size. It'll show you the minimum maximum. You don't need that, right? What you need is you're gonna, if you go down, you cursor down, it'll show you the sample mean and standard deviation as well. Okay, and you do that for all the L1 and L2, and then you do by hand the rest. But I don't think your final one have something like that. I'll let you know. I'm trying to this weekend you have the final practice up and running. And on the day of the review, we'll review some problem, and we're gonna do some Kahoot. Have you guys done Kahoot before? It's fun, right? Does the music make you nervous? But it's extra credit, right? It's no harm done. You don't get it, it's fine. All right, let me go back to the last slides. Okay, can I start now? Okay, let's see. What was that? Anthony was talking about? What was A? Oh, all right. Okay, Carly. All right, Carly. Okay, Anthony right here. All right. Different. Yeah, similar to Carly. Stephanie. Kyle. Okay. Maggie. Maybe something is wrong. Dan. Oh, you by Dan, you look by looking at the graph, how steep your graph is. Do you remember in math, right? If it's steep, then your slope is what, close to 1. If it's not, then close to 1. Okay, so all right, so let me do the negative one first. Let's do the negative one first. So which one is look negative to you? Yeah, B and F, right? So negative, I have negative 0.7 and negative 0.3. So B should be, yeah, negative 0.7. And then F should be negative 0.3. So it's less steep, right? It's less strong, yes, and more scattered. Okay, so for the positive, what is the most positive one you'd see? Yeah, this one, this one. So it's 0.99, right? That's 1.99. The steepest one I see. What's next? What's the second steepest? E. Look like E. Yeah, 0.9. 0.9 for E. And then C and D, you gotta choose. Oh my God, it's so difficult to. Oh, good God. Oh, that is so. This is. No, they're different. Oh, they're the same. No, they're different. They're different, right? Yeah, C more positive because the point is kind of tight, more tight together, more close together. So C more positive 0.5. And then I don't see any shape there. It's just kind of making to like a little ball to me. So 0. Okay. Now for your quiz, we done, but I'm just gonna talk a few things about your quiz. It's gonna be all chapter 4, literally in these chapters. So just study this chapter, okay? It'll be easy, not difficult. All right. And the quiz will be on. Yes, I changed the date. It'll be this Thursday. Okay, Thursday, because I don't want you to forget. All right. Have a wonderful day, and I'll see you on Thursday.
Have a nice one.
Yeah, you too. Thank you very much. Oh yes. Oh, please don't leave yet. Thank you, Randy. I forget. Oh, let me take attendance first, and then you guys can leave. Okay. Today is 4th. Fatima,
Yes.
all right, thank you. Angelica, not here. Not here. Maggie, Roman, you here? Roman, he was talking to me earlier. Dan,
I'm here.
thank you. Yeah, I got you. Kiona,
Here.
thank you. Brendan. Logan. Madison. Rosa. Max. Maximilian's here. Thank you. Amat. No, he's dropped. Randy. You here? Yeah, you're here. Sorry, Randy. I was thinking Rami. Randy, Larissa.
Here.
Right, thank you, Larissa. Melody. Oh, I skipped one. There's 4. Is Ryan's here? Melody. Ella. Oh, here. Thank you, Ella. Carly's here. Kyle's here. Jade. You should talk to me. You too. Thank you, Kyle. Mallory. Jessica. Oh, thank you, Jessica. Anthony's here. Daniel.
Here.
Thank you. Sally. This is here. Tyler's here. Fatima's here. Sarah. Autumn.
I'm here.
Oh, thank you, Autumn. Stephanie's here. Rami, you there?
Yeah, I'm here.
Thank you. Kareem.
Yeah, I'm here, Professor.
Thank you. Mohammed.
I'm here.
Thank you. Thank you. Have a good one and see you on Thursday. Be here in person, okay? So we can take the quiz.
No, you go first. What if I see slide 17?
On what?
Slide
17 of the same chapter 4? Oh, okay, yeah.
Yeah, before I knew that the quiz was that day, I was scheduled to work like all day long.
Oh,
Great.
yeah. 17. Oh, okay. There's nothing there. There's nothing. Oh, 17. There's nothing there. Oh, you that? Oh, okay. You have a question?
Yeah.
Oh, okay.
So for this one, I thought you said on the, like, the video when you're going over the practice exam, that if you had like a decimal and it had to do with like any kind of people, you just leave the decimal.
No, no, no.
letters.
Expect value.
Okay,
Expect value, you leave it alone. If it's satisfied, you write.
okay. And then the other question we had was for this one, I thought it was kind of brief, but the answer was still yes, because each part was rejected, but I missed like this part here. I think I didn't write, what was it, like 33 point
No,
something?
you have to say out. You have to explain. Otherwise, it's just, people just rely from the result and they say it out.
Okay, so this is still wrong here.
It's not wrong, it just, it does not count because you already have the answer. That's what you said.
Okay,
No.
okay, all right, that was it. That's okay. There's nothing else we can do.
Well, there's, so yeah. One, number two.
Okay,
Yes.
and then I was gonna tell you too, the bonus check marks, the dates are a little bit off for those at the top.
Oh, I don't put digits, so what?
Yes.
Oh, it was someone else then. It must
You
have
can
been.
fix it.
Okay, I wasn't sure if I could type on there or
You
not.
can type on.
Okay, all right, thank you.
Professor,
Yeah.
I have a presentation that I have to do
Oh.
this Thursday.
On Thursday, okay.
Yeah.
But you still have to, presentation is not with the same class as I do.
What's that?
What time is your presentation?
It's at 3:15 until 4 o'clock, but then I have some.
Wait, you take the class, you register for this class. What kind of presentation is that?
It's for Sigma Xi. It's a research conference.
Oh,
Yeah,
okay.
yeah.
Mm,
I know,
well-
I wouldn't have just
oh, no,
deliberately
you can
scheduled
take
over.
the quiz in the beginning of the class. We're gonna do that.
I don't think I'll have time for that. I have a class right
Oh, okay.
beforehand.
So,
Could I take
can you do
tomorrow
online,
or-
take online? Okay.
No, I'll be, they're gonna have presentations, so I probably can't take it online.
What time your presentation end?
So the day is 3:15 until 4 o'clock is when I'm like
Okay.
speaking, not speaking to a crowd, but there's people walking around and
Mhm.
come to my poster. At 4 o'clock, there's a, like some presentations that they do, like some like higher up researchers, they'll go and present what they want me to. And then after that, there's a dinner at 5
Okay.
o'clock.
Well, my best bet is, let's see,
I have a
you want to take it before Thursday?
Probably,
Oh,
yeah.
okay. So let's see, what work best for you?
Tomorrow I'm free most of the day.
Me too. Well,
Okay,
I'm
great.
not free, but I'll be in school like all day.
Yeah.
So
I don't
just
have
email
class
me,
most of the
email me
day.
what about,
Like anytime after 1 o'clock.
okay, I'll email
is
you what
great.
time you should.
Okay.
I'll email you.
Great.
You
You do well on most of the quiz though, right?
Mhm.
You get the lowest you drop.
Oh, yeah.
you can take it before, it doesn't matter.
Yeah. let me
Or you
just
can
take it.
drop. I'll email you and you decide what you want to do.
I'll do that.
What about you? You
I'll be
okay? Good job.
Yeah, just here for most.
Yeah.
Are you guys in the same club or something?
Oh,
No.
we went to high school.
We went to high school
Oh,
together,
oh,
we
that's
know
so,
each other.
well, that is so cool. Nice. All right, yeah,
Take care.
good luck,
Bye,
see you.
Professor.
Thank you. All right, Kareem's here.